we have a parametrized curve, RT, equal to 3 sine t, 3 cosine t, 4t. We want to find three things. The unit tangent vector at t, so it's capital T of t, the unit normal vector at t, capital N at t, and the curvature at t, capital K at t. Now, our curve is just going to be a helix. So you draw in your cylinder, you can put your helix in. We want the unit tangent vector. So what are we going to do? Definition is take your r, take its derivative, divide by its length. So the derivative of r is going to be, okay, we'll have 3 cosine t minus 3 sine t, 4. The length, that's 3 squared cosine squared plus 3 squared sine squared plus 16. That's going to give me a length of 5. So we divide by 5, and that gives me 3/5 cosine t minus 3/5 sine t, 4/5. So that's our unit tangent vector at t. Next, our unit normal vector. So here, we're going to take our unit tangent, take its derivative, then we're going to divide by the length of the derivative. In this case, the derivative is going to be minus 3/5 sine t minus 3/5 cosine t, 0. Take its length, it's going to be square root of, okay, 3/5 squared cosine squared plus 3/5 squared sine squared, collapses to a 3/5 squared, square root, so we get a 3/5. Divide by 3/5, then I'm left with minus sine t minus cosine t, 0 for our unit normal. The check, so we expect that the unit tangent and the unit normal are perpendicular. So if I take their dot product, we should get 0. So in this case, you multiply through each coordinate, take the sum, and then you see we in fact get 0. So these are perpendicular. Now, the curvature, we're going to take t prime length over r prime length. In this case, it's going to be 3/5 over 5, gives me 3/25. So that's our curvature. That means if we take the best fitting circle to our curve at the point, the radius of that circle is going to be 25 over 3. Bonus vector, the unit binormal vector. So this is defined as the cross product of t with n. Now, note the length of a cross product is the length of your first vector times the length of your second vector times the sine of the angle between them. Length of t and length of n, these are both unit vectors, so their lengths are 1. The angle between them, they're perpendicular, so the angle's 90 degrees, its sine is equal to 1. So the length of the binormal is 1, so it's actually the unit binormal. Now, we also have, since I'm taking a cross product, the cross is going to be perpendicular to your original vectors. So what we have here is, okay, we have t, n, and b. They're going to give us 3 mutually perpendicular vectors at any point on our curve. So we call that the Frenet frame. So if you take t crossed with n, in this case, what comes out? So if you work out your cross product, so here I'm putting c and s, abbreviating sine and cosine, then we're going to get 4/5 cosine t minus 4/5 sine t minus 3/5. Your check is going to be the binormal dotted with the tangent gives you 0, they're perpendicular, and the normal dotted with the binormal also will give you 0. Okay, again, because they're perpendicular. We could also check that this thing has unit length, so if you take the sum of the squares, you'll see that you get 1.